Assalamualaikum warahmatullahi wabarakatuh. My name is Amal Ashahmi bin Abdul Manan, matrix number MA22081. And today I will be presenting Six Sigma DMAIC, which is the Define, Measure, Analyze, Improve, and Control. So, for a brief introduction, Six Sigma has two strategies, which is the DMAIC and DMADV. So the difference between DMAIC and DMADV is DMAIC is fixing, meanwhile DMADV is creating. DMAIC is a reactive where we analyze and improve, while DMADV is the proactive where they measure and analyze. And lastly, DMAIC is the control, while the MADV verify, which is for validation versus control. So what is Six Sigma? Six Sigma is a data-driven methodology to eliminate defects and reduce process variation. So we aim for 3.4 defects per million opportunities and aim for 99.99966% process accuracy at Six Sigma level. This Six Sigma is pioneered at Motorola in 1986 and popularized by GE under Jack Welch. Now it is a global standard for every manufacturer. So for the core principles, firstly, it focuses on the customers and it is driven by data and facts, and lastly, strive for continuous improvement. So Six Sigma has a few belts. We have the white belt, the yellow belt, the green belt, the black belt, and master black belt. White belt is the awareness, so where the person understands the Six Sigma basic and support local project and improvement activities. The yellow belt is the contributor where they participate in the project. And the green belt is the lead project leader, which leads smaller project part-time. They are trained in DMIC and the core statistical tools. And lastly, black belt is and next is black belt, which is the full-time experts. They lead complex projects full-time, and they also coaches green belts and drive straight to result. And lastly, we have the master black belt. This is the pinnacle of Six Sigma. They are the strategic coach where trains and mentors belt, shape strategy, and champion for culture of improvement. So Six Sigma strategy, firstly we measure what matters. We establish the baseline metrics. We translate business plan into measurable CTQ. We use dashboard to track progress, and we quantify the costs using CPQ. Next, we must understand the variation. We must distinguish common versus special cost variation. We use control charts to detect signal versus noise. We target the vital few root causes, which is the Pareto principle. And we validate causes statistically before acting. And the last strategy is to sustain the gains. We embed improvement into standard work and SOP. We use mistake proofing to prevent reoccurrence and monitor ongoing SPC chart and audit, and lastly build a culture of continuous improvement. So roadmap to excellence, from organizational alignment to sustained breakthrough through performance. So we have first is the leadership commitment, then we have the strategic alignment. We proceed with project selection and then execute it with DMAIC, and lastly we will review and replicate wherever possible. So for the first step, we have the define phase. So define phase for problem statement. Firstly, what problem are we solving? We must clearly articulate the business problem in measurable terms. We need to state the impact on customers, revenue, or operations, and avoid jumping to solution. Focus on the symptoms and the facts first, and use data to validate the problem exists. So for the problem statement, we can use the templates such as this. Uh, like currently, the process is causing this problem, resulting in the impact. Then the goal is to reduce or improve the metrics by target by the date. So that is the problem statement. Then we have the project charter. Firstly is the business case, why this project matters to the organization and stakeholders. Second is the scope, what is in and out of scope for the improvement. We have the goals and metrics, the measurable targets, such as defect rate, cycle time, and cost saving. And lastly, for the team and timeline, we need to know the sponsors, champion, belt, team members, and other key milestones. So moving on, for define, we have the VOC, the voice of customer. We need to capture what customer need. We will be doing the surveys, interviews, we analyze complaints, we translate VOC into critical to quality requirements and prioritize using Kano model analysis. For CTQ3, we have the customer need into quality driver into CTQ requirement. For example, fast deliveries means on-time arrival, which we must require 95% on rate. So that is the SIPOC diagram. What is SIPOC? SIPOC is the supplier, the input, the process, the output, and the customer. Supplier is who provide the input. Input is the material, the data, the resources. The process is the high-level step that create the output. The output is the product, service, or information that we are producing. And the customer is who is receives and affected by this output. So to create a SIPOC diagram, we need to define the process. Then we move to the identify the outputs, then determine the customers, specify the inputs, recognize the supplier, review and validate with stakeholders, and lastly choose a tool and format. So the key takeaways for define phase is problem statement is clear and data supported. Then we have project charter approved by sponsor. VOC collected and CTQs are identified. SIPOC completed and processes boundary set. So we can move into the measure current process performance, which is the measure phase. Now the measure phase. Firstly, we go to the measurement plan. What we will measure? We will identify key input, process, and output variables, KPIV, KPOV. We define operation definition for each metric. Then determine the data collection method and sampling strategy, and assign data owners and collection frequency. This is schema. So for process capability, CP and CPK, CP will have the process capability, which is spread relative to spec width. CPK is the centered capability, which accounts for process centering. Sigma is the sigma level, the defects per million opportunities. DPMO is the defect rate, defect per million opportunities. So our target is CP more than or equals to 1.33 and CPK also 1.33, which is for sigma, or we must aim for better, which is the Six Sigma. For measure, we have data collection and sampling. So we have a few strategies that we can do for sampling. Firstly is the random sampling. So it can remove the selection bias. We stratified sampling, so it can capture subgroup variation. Sample size must be statistically sufficient and avoid data cherry picking, collect over time. So the most common pitfalls that can cause problems in the data collection and sampling are the firstly collecting data without clear operational definitions. Then using convenience sampling instead of random, which leads to imperfect sampling. And then ignoring measurement system error, which is the cache R&R. And mixing historical and new data without proper validation. So next is to cache R&R measurement system analysis. Firstly, we have the repeatability. Then we see for the reproducibility and the study variation, where less than 10% is acceptable, 10 to 30% is marginal, and more than 30% is borderline unacceptable. And lastly, is the percentage contribution, which measurement system should contribute less than 1% of the process variation. So the takeaways for measure phase, we need to check for the measurement plan defined with clear operation definitions. Then the data collection completed with sufficient sample size. Then measurement system validated via gauge RNR. And baseline process capability established, which is the CP, CPK, and DPMO. So then we can move to the analyze phase to find the root cause. For the root cause, we have the root cause analysis tool. Firstly, we have the fishbone diagram. It has a cause and effect diagram where we explore the 6M, the machine, the method, the material, the measurement, the mother nature, which is the environment. And second, we can use the 5 whys. We will ask whys 5 times to drill down the symptom to root cause without jumping to solution. Then we can use the Pareto chart with using the 80 to 20 rule. We can identify the vital few causes responsible for the majority of the defects. And then we can use the process value analysis to map each value added, non-value added, or required non-value added. Then this is the fishbone or Ishikawa diagram. These are the 6 M categories, as I said before. We have the man, the machine, the method, the material, the measurement, the mother nature. This is how the fishbone diagram looks. And how to use it is we write the defects or the problem at run, and then we draw the 6M bones, and then we brainstorm the causes per category and vote on most likely root causes. Then lastly, we can validate with data before proceeding. Next, we have the hypothesis testing. So using statistical validation, we can form a null hypothesis and alternative hypothesis. We select appropriate tests. We are using the t-test, ANOVA, chi-square, and choose a significance level of 0.05 is the standard one. And reject a null hypothesis only when p-value is less than alpha. So these are the common tests. The common test comparing means using two group t-test. We have the ANOVA for 3 plus group and chi-square for proportion. Normality check for Anderson value. So for correlation aggregation, we have R correlation coefficient, which is the strength of linear relationship, -1 to +1. We have R squared, the coefficient of determination. This is the percentage of variation explained by the model. The p-value is the statistical significance, where less than 0.05 mean is very significant. And we have the transfer function. So our goal is to quantify which the inputs are most significantly drive the y, which is the output. So the takeaways for analyzed phase, the root causes identified using fishbone and 5 whys. Pareto analysis pinpoints the vital causes. Hypothesis test statistically validate the root causes of the problem, and transfer function is established. So after this is finished, we can move on to the develop and improvement. So this is the improvement phase. Improve phase. First is the solution generation. So the ideation method, we have the brainstorming, where we generate ideas without judgment. We have TLIZ, which is the systematic innovation using inventive principles. We can do also benchmarking where we learn from the best in class process. And lastly, we have the DOE, which is design of experiments to test multiple factors simultaneously. So solution selection by matrix, we evaluate solution by the impact on root cause, the ease of implementation, the cost and resource requirements, and the risk of failure or side effect. And lastly, the speed to implement. For the OE, we have the full factorial, then we have the fractional factorial. The full factorial is to test all combination of factors, comprehensive but expensive. Fractional factorial test a subset, efficient screening. This is more efficient screening for key factors. And three is the response surface. We optimize the response by modeling curvature between factor levels. And lastly, the Taguchi methods. This is the robust design. It reduces sensitivity to noise factors in real condition. So for improve, next we have the pilot and validation. Pilot testing step, we run a solution on small scale before full deployment. Then we collect data using same measurement plan as measure phase. And then we compare pilot result to baseline performance. And if the document issues, we adjust solution and retest if needed. So the success criteria for the pilot is improvement meets or exceeds CTQ targets, statistically significant improvement confirmed where P is less than 0.05 compared to baseline, and no new defects or unintended consequences introduced. Process capability improve where new CPK is more than 1.33. So the implementation plan for improve phase, we have the prepare. We finalize the solution, we train staff, update SOP and work instruction. We communicate with stakeholder, explain why and what to expect. And then we execute where we roll out changes in a control-based approach. And then we monitor, where we track KPIs daily or weekly and compare against our target. And lastly, we will adjust and we escalate to blockers to sponsor. So the takeaways for improved phase, firstly, the solution selected using criteria-based decision matrix, and then DOE optimized by key process parameters. Pilot demonstrated statistically significant improvement. Full implementation executed with communication plan. And lastly, we can move on to the control and sustain. Again, the control phase, there are a few elements for control. We need to define control points and set control limits, and then specify the action plans of our out of control condition and assign ownership of each control. So these are a few statistical process control. We have the S bar and R chart, the individual chart, IMR, the P chart and P chart, the Kusum or EWMA chart. So for mistake proofing, we will use Pokayoki. Where prevention versus detection. Prevention Pokayoki stops error before they occur. Detection Pokayoki catches error. Contact method, physical features prevent incorrect assembly. Contact methods ensures correct numbers of step or parts. So examples by level. Level 1, we have the elimination, where they design to make error impossible. Second is the prevention. Fixture or pin or guide prevents wrong step. Detection is sensor or checklist catches error before output. And lastly, level 4 is the mitigation, which minimize impact when error does occur. So documentation and knowledge transfer, we have 5 steps. Firstly is to update the SOPs, and then we train all operators and supervisors on the new method and controls, and we visualize the visual control, and then the handover, transfer the project ownership to process owner, And well, we summarize with the lesson learned. So the key takeaways for control plane is control plane implemented with SPC charts and reaction plan. Okay, measures are installed to prevent recurrence. SOP updated and all staff trained on new process. Project handed over to process owner. And then the DMAIC project complete where the gain is sustained. So for conclusion, DMIC value synthesis, we have this, we will have standardized rigor, the structure 5 piece enforces standard academic and industrial problem solving protocols. We also defect elimination by striving for 99.9996% accuracy, which is 3.4 dpm. And then we sustain saving using control plans, real-time specific chart, keep pocket to standard, and preventing procedural decay and actively secure financial. So the strategic essence for the IC, we can demarcate process variation, we can log in changes via XOPs and root cause validation we use only. So we can avoid costly implementation without statistical verification. So these are the references for the slides. That's all from me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.